Hey guys, super impromptu early Saturday morning review. I started checking your reviews this morning and realized that you were stuck on a lot of the same problems, and I wanted to go over and do them. Your returns are in there. I checked everything and sent them back. You did well. I gave you guys all but good grades, no worries. My answers are up, and yes, you can open them. I'm really sorry about the errors on the document. I attached my screenshot too, so you know I'm not going crazy. Everything I tried to save and change for yours has not changed in the past 3 days. No idea why. So, I don't know why you didn't have a temperature when I did. I'm super sorry about that. I'm sorry about the weird spacing. Again, it was okay on the document on my computer, but more importantly, we need to go over some of the questions on here. I will be in office hours Monday. I'll be able to do that too. But you guys did good in the first page. Just make sure you look at how to write partial pressures, KP. Couldn't type it, but you'll see that on my answer. That's not a big thing. Like the fact that you didn't write it as P of H2O. Just check out how I did. My big concern, other than there being no temperature, your equations were great. So just have a look at mine for the N2O4 reaction where I asked you to calculate Kp. For your ice chart, this was the thing. And this was hard from the packet because the example in the packet went the other direction. That's what most of you did on this one, was not be sure which way the reaction was going. And it sounds like I'm blowing it off when I say it, but what I know is since I started with H2 and I2, equilibrium means I'm going to have some of both. So I must be making the missing piece. I must be using H2 and I2 to make HI. That's the big thing. I'm making HI. So, no HI. You did great. You had your molarities from your liters. Perfect. You didn't have any HI, and a lot of you got to this point just fine, where we had H2 and I2 and then HI. We were good on that. And you knew 0.03 molar, 0.03 molar, and nothing. But we got to make the nothing. Here's another thing. Because it was 2 HI in the balanced equation, you also need the 2 reflected in your change. So, since I've got H2 and I2, I'm going to have to be losing them to move on. Because I have HI coming up, I'm going to be gaining it. And not just gaining it. From the reaction, I am gaining 2 of it. H2 plus I2 yields 2 HI. So my changes are going to be 0.03 minus X twice. I ran out of room for my molarity. And then 2X here. When I write my expression, and I'll just sort of squeeze it in up here, K is going to be H2, HI squared, because the coefficient's 2, over H2, I2. Good. So let's sub in. So, K, and you should still be able to see this just barely. All right. I'm going to have HI squared. So I'm going to have 2x squared over 0.03 minus x, 0.03 minus x. There we go. Now, what else did I know here? I want to figure out my equilibrium constants, and I'm given 45 for K. Awesome. What I see here is that this is going to be a problem to solve. It looks quadratic-y, but it's really not, because what I know is that 0.03 minus x times itself is the same thing as that squared. So what I'm going to do is say, okay, I'm going to take off that squared, I'm going to take off that squared, and I'm going to take the square root of 45. Am I cheating? Oh, a little bit, but that's okay. When I solve for x, I get x equals 0.0231, And that's not too bad because it's going to give me 0.0462 for my equilibrium constant of HI, that twice. And it's going to give me, it looks like 0.0069, 0.03 minus that for my concentrations of H2 and I2. Not too bad to solve from here. This was your concern. This was my concern, is knowing which side's gaining and which side's losing. So hopefully that helps. You have more questions on that, let me know. You guys did well on comparing Q and K. Very good. Now this gas phase reaction, Le Chatelier's principle, you did really well on most of it. You were getting the addition subtraction well. Catalysts never change the position of an equilibrium. They just affect how fast you get there. The trick is catalyst is always no change for an equilibrium. That's probably going to come back up somewhere. I think the heating and cooling ones are tough. I think when we do the heating and cooling, the trick on that, heating and cooling, is to remember that for an exothermic reaction, heat is a product. So if my reaction's exothermic, it's going to be A yields B plus heat. Heat's produced. In an endothermic reaction, A plus heat yields B. So for an exothermic reaction with a negative delta H versus an endothermic reaction with a positive delta H, it's going to affect which way your equilibrium shifts. If I cool an exothermic reaction, I'll shift right because I'm taking away a product. The example in your questions took away the reactant because delta H was positive. Taking away a reactant shifts your reaction left. So those were two that were missed. Pressure. If you're given pressure, if you're asked about pressure of a gas phase reaction, which this one is, count your number of moles. 3 on the left, 2 on the right. You'll shift to the lesser number if pressure is increased, because no matter what kind of gas you have, a mole takes up the same amount of space. Those were my concerns on these. Your Q calculation was excellent. You guys did well with combining your KCs, and your question answers, your word answers were good. Please stop in 11 o'clock Monday if you want to go over this stuff, or email me, especially if there's anything you want me to make sure I go over. Email me over the weekend once you guys see this, or Monday morning once you see this, and I'll answer your questions. Hope you catch this in time. Have a good one.